We have this lesson that we will talk basically about interfaces, what they are, how to use them, and how they are used. We will talk about inheritance in smart contract inheritance, which is a very important topic as well, and it's used basically always. And we will talk a little bit about OpenZeppelin. We'll talk a bit about fallbacks, and then we will take a bit of time to actually code a real example, like because the last lesson we were doing that first smart contract, which was pretty like there wasn't any goal to achieve, let's say, stuff like that. But in this lesson, I would like to take, I don't know, half an hour, let's see with the time, but to actually try to do something more real, let's say, right? So, for who didn't participate to the first lesson, you can find like I don't know why I called it V-Chain Masterclass. It should be Solidity Masterclass, but whatever. So we have this internal repository here with the previous repository that we started in the last week with the template. So you can go and see the contract, the first smart contract that we started to code. So yeah, just pull this repository. We will work on this one. I will push all the new code that we will write in this lesson here as well. So just, yeah, take it. You have all the README to how to install, to how to run it, and so on. So before actually starting, I wanted to take a few minutes to talk about one thing that is here in this, let's say, yeah, in this repository, but it comes right from that template that for Hardhat that I showed you. So, and it's about actually the deploying, because I was looking at it and I was like, that could be a bit confusing, right? Because we have this script here, deploy, that actually calls another script, which is called deploy, right? Like get or deploy contract instances. So I would like to explain why I added it here, but I can do it in a simple way. So the simple way is that originally you don't actually need this, right? So when you need to deploy a smart contract, what you do, you just take this thing here, which is all the deploy process, right? So we take the factory contract, simple storage, we deploy it, we pass the parameters, whatever parameters are needed. We wait for the deployment, and then we have the address, and our smart contract is deployed, right? So let's take this and put it here. So instead of doing this like get or deploy, blah, 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 we just put it in here, right? So we import our headers. Okay, we need the owners. So we take it from here, put it here. So we say console log, deployer address, blah, blah. Okay, we do this, and then simple storage is actually this one. Okay, and yeah, we don't even need this. It's like this is already enough. So at the moment, we can even just completely delete this file here. Okay, we delete it. We remove it from here. I'm not sure if here it's being used. Yeah, it's being used. So let's just completely delete it. Let's for a second just comment this code. Let's comment also this code here. Okay, so now in here, this is not exist. Okay, so we just move it, right? So if we say yarn deploy testnet, we get some error. Invalid mnemonic field. Okay. This is the testnet mnemonic. Sorry, it's actually the solo mnemonic. It's filled with vet and VTHO. So we deploy in testnet and it's doing its job, right? So deployer address is this one, which is the correct one. Let's wait a bit, and it actually did not console log the address because I forgot to put it. Yeah, I forgot to put a console log in here. Okay, so it works, right? But now in our test, what we need to do, so we had this like contract should be then should deploy successfully, right? So we need a contract. So right now, what we need to do in our test, we need to do the same thing. We need to do this thing here. So we add it here. We say get it. We need to take the owner. We take the owner. So we have this, and the test can run. And here we had another test, and it was using this one. So we need to do the same thing. So you can already like imagine why that was done. So we start to have a lot of repetition in here, right? So first of all, like this is just for two tests. We added it 2 times, right? So this is the first problem, the code repetition. And let's just yarn test. So this is the first problem, that you repeat your code. But the second problem is actually that every time you deploy, you run one specific test, you redeploy the contract. Okay, so if I add here, like I can set value that, you will need to again redeploy it and so on. So actually it's not mandatory because, with tests, like even if I don't redeploy it, but I just create a sort of before in here, before all, and before all I just deploy the contracts, it will work. Yeah, I don't know why it's complaining, but this thing will still work, okay? Because it will just deploy it one time, and then inside the other functions we will use that contract. But this will basically create right now a sort of dependency, right? So if tomorrow I add another test in the middle, I add something here, maybe this one won't work anymore because in here we say like, okay, the initial value is 42, but we actually changed it here. Okay, so something changes in the middle, all your tests basically are broken. So if you want, let's say, to have, I don't know, 2 tests like that have the dependency, so you don't need to redeploy, but then you want one that actually redeploys the contracts to start from zero, then it's basically, or you add it as the last one, like you need to think about all this stuff, right? So with the file that we created here, like the solution would say like, okay, let's create a helper, right? So we go here and we say like deployer helper, something like that. That what we do here, I don't know, maybe something like this. So what we do here, we actually move everything from, and let me just, for simplicity, go back here to copy paste some code. So what we do, we say like, okay, let's deploy the contracts in there and let's return them, right? So we do this one time here. We import ethers, okay, and we say like, okay, this function will return what? Will return the owner, and will return the content, right? Okay, so now we can say export from deploy, deploy helper. It's not working. Should work. Am I missing something? Maybe it's fast. Let's reload. Like this. Constraint. Okay, but whatever. So what we have here right now, then we can just say like, okay, instead of doing this every time, we can say like, okay, I will take the owner, and I will take the contract, and I will take it from, okay, let's, instead of calling it main, we can call it deploy contract, contracts instance, contract. Okay, something like this. So we can say contract instance from here. Okay, and we will have our owner and our simple contract storage. But another thing that but this way, basically every time we call this function, we just basically avoided some repetition, right? By putting this in a function. But what we can do, we can add some parameters. So we can say like force deploy, right, like this. And we can say, okay, if, so we can specify some global parameter like let simple storage contract. And when we set it, we say uh, global global is equal to this one. And if force deploy is false, so if we don't want to force deploy, let's say, yeah, we don't actually need this one. Then we say return this. And this is of type contact, like this. Now what type is this one? Yeah, like this. Okay, so basically right now, uh, this way we can use both we have both the capabilities of this before all. So we can like say, for example, I don't want force deploy false. No, it's just false, sorry. So we say false. So this way we are not redeploying the contracts. Otherwise, we redeploy them. Okay. So now we have like our helper function to deploy the contracts, and we have another function which is deploy to where we do the same thing, but it's actually used to deploy for production, right? So the reason why in the original repo that you have here, this function, in this deploy all, we call the deploy get or deploy contract instances, is because this way we don't have basically two identical scripts that are doing the same thing, but stored in different places. So now you add, I don't know, another argument to the contract. You need to update it both here, okay? Because you will have like your arguments. So you will say like, I don't know, the value of one for something. So you need to update it here. You need to update it also here. And if you like, if you have quite a few contracts, it could become a bit complicated to remember to do all that stuff and so on. So with the other way instead, so if we just remove everything, just dash all, okay. So if we remove everything, it's a bit more easy to maintain in the long run, okay? Because this script here just calls, like you have one central part where you're doing all of this, right? And so yeah, that I just wanted to touch a bit on this because it could lead to some confusion, like why is this happening? But for you, like in your own code, like if you don't like this approach, you can change it. There are also other packages that you can use to actually handle your deployment differently. For example, for hardhat, you have also hardhat deploy. So yeah, let's see. Yeah, which is another package where you handle your deployment in completely different way. Yeah, it's basically a different way to handle your deployments. So if you don't like this way, you can every time like just switch and use something else. Okay, apart from this, uh, let's get back to where we stopped. So we had our first smart contract. This contract had an owner, right? And this owner was set during the deployment. At the moment of the deployment, how? By using the constructor, right? So in the constructor, we set this owner. Message center message is a global variable in Solidity, same as, for example, block. We were saying, right? Right. So we can say block, we can get the chain ID, difficulty, gas limit, number, and so on. So those are global variables that you can use in your contracts. So we were setting the owner, and we create the modifier to check that whoever is calling a specific function is actually the owner. So you do the checking here. If this is not, if this is true, so the sender is different from the contract owner, we revert the transaction and we basically log this error, right? So we say unauthorized access, and this is the user that was trying to call. Then we had a few functions, one to add the user, and you see the only owner modifier here. We're doing some logic. We emit the event saying like, hey, a new user was added. Then we have a getter function to get the owner and another getter to get the user. So this is where we stopped. So let's restart from here. And as I said, one thing I would like to talk about now are the interfaces. So interfaces is basically how also in other languages, like in PHP or whatever language, like you say, you define a structure of something. So you could say like this controller, if we think about backend, right? You could say like this controller needs to have the specific endpoints or the specific, the specific endpoints or the specific functions in it, methods and so on. So here is the same. So you are saying by defining an interface, you say like, okay, the contract that is inheriting this interface that is saying like, hey, I'm following this interface must absolutely write, like incorporate the following functions. If you are not doing it, an error will pop up. Okay, so let's just try to see it. So we say like usually the standard is that you put the I in front, which symbolizes interface. So you say I first smart contract dot solve. So this is basically the interface for the first smart contract. Okay, and you have like the beginning is the usual. So you need to specify the license. So let's just copy it from here. Let's just copy also this one. So you need to specify the license. You need to specify the Solidity version, that the contract that will implement this interface will need. And then you have this keyword, which is interface. Okay, interface and the name of the interface. So smart contract. Okay. So this is basically like the start. Okay, so this is the basic way of saying like, okay, I want to create an interface. And there are a few rules for when you write an interface. So first of all, inside an interface, you cannot say like you cannot define a variable. Okay, that's not the space for the, like, you could, there are some cases where you can do something, but it's usually it's not for interfaces. Okay, in what you put in an interface is just like, okay, what are the functions? Okay, the functionality. So what are the functions that the contract will need to implement? So if you, for in our case, if you look here, for example, we could say that, well, two functions, right? Get user, sorry, add user and get user. Those are basically what's all this is about, right? So you say like function add user, and the way you do it, so if you go here, what were the parameters? It was a string, username, the age, an integer, and an others, right? So you basically write the same thing until here with all the parameters, but then you stop and you put it as external. So this always must be external, defined as an external function inside the interface. So I cannot say this is a public view function, okay? You will see error. This is actually an external function, okay? Then what we had another function, which is function get user. Okay, so this one is an external. We can even remove the view. So, and we need to specify the return as we were doing here, right? So function get user, return, blah, blah. And here it's, I was saying you cannot define variables in the interface. And this is the only case which is kind of the limit, let's say, where actually in here I'm saying I want to return a user, right? But this interface doesn't know what user is because user was a struct that we created. So it's kind of allowed to put structs in here because I put the struct, so this function knows what I'm returning, okay? But it's a bit of like on the edge, let's say. It also depends on a bit of philosophies that from people around. So, okay, so we define our two functions. They are both external. What else we can put inside an interface? We can say like, hey, apart from like the functions, I also want that the contract to have like an event. So we can say like new user added, like the contract that will inherit, that will use this interface will have like an event and an error. Okay, and this is basically like initializing also those two. Okay, you're basically declaring them. So how to use this interface at the moment? So I could just basically pass this to whoever and say like, hey, I don't know, and this is how you could also use interfaces. So before even coding the smart contract, one thing you could do is like really think about, okay, how I want my contract to behave, what I want my contract to do, right? So you just write down like, hey, yeah, I would like a contract where I can add a user, I want one to get the user, I want, I don't know, whatever I want, and you write the functionalities, the functions in here. That's one way of doing it. And then you start writing your smart contract. And to specify that this first smart contract is actually using that interface, you say is, and this keyword is used for inheritance, and we will touch it in 1 second. But you say is, and what it is, it's basically the I first smart contract. Okay, and we need to import it, so we say import I first smart contract from this file. Okay, and now we have some errors, as you can see. Why? Let's look at them. So first of all, since I defined this struct inside the interface and this event and this error, if I try to compile, the error that will result is saying like, hey man, you like we already have the like this event, it's defined twice, right? This struct user is defined twice as well, so on, because it's true. We actually already declared inside here, so we don't need it here. We can remove it. We can remove also this one, and it will just work. So let's compile. Yes, it just works because it like this contract knows what a user is. Why it knows what a user is? Because we defined it inside this interface. This contract also knows like what this error is because it's defined in here. Okay. So now what about the functions instead of those functions? We declare them as external. So if I, for example, I comment this one here, you will see it's already red. If I put my mouse over, it says like, hey, this contract should be marked as abstract. What is an abstract contract? An abstract contract is just a contract like this that you cannot actually deploy because not all of the functions that needed to be implemented are actually implemented in here. Okay, so if you cannot deploy it, what you can do with it, you can use it for inheritance, so you can create another contract that inherits this one, and we will see it later. But you cannot deploy it basically, but it will compile at least, right? But we don't want an abstract contract. We just want a normal smart contract that we deploy. So in this case, even if we try to compile, it will say like, hey, you see, like this function is missing. You did not implement this function. So we need to do it. As I said, in the interface, in here, we declare this as an external function, but in here inside our smart contract, we declare it as we want. We can put external, and if you remember, we were saying external, it means that only like this function can be called only from outside the contract. So from the front end, from the inspector app, or from another contract, for example, but I cannot do something like this. Like, for example, you could say like, hey, I want to add a check in here, like check that this user does not exist already. So how we could do that? We could just basically check if we already have some value in users with this user address, accessing the storage. Okay, that could be uh, even the best way, let's say, maybe. So we do something like this. Okay, so we say users, we check, and we check the address. Because if you remember in the first lesson, I was saying like every time you declare a variable, it is already automatically initialized with some default values. So addresses are initialized with the default value of 0x000. Booleans are initialized with false, and so on, right? So what we are doing, we check like, hey, if I'm checking, I'm getting the value out of this mapping, and the user address, and as I'm telling, like this is a mapping to a user struct, and the user struct has a username, age, and user address, right? So I'm saying like, and if the user address inside there is 0, it means that it's the default initialized variable, right? So it means that sorry, so it needs to be 0. So it means that uh, like that variable was not initialized with another username, user address, and so on. Otherwise, return an error that the user already exists. But what you could do, instead of calling this, you could also say like, you could call get address, right? So you could say, instead of saying user address, you could say, you could do like this, where you put the user address, yes. But you see, it's already giving me an error. Why? Because it's not visible. It's saying like, hey, I don't see this function. Why? So it doesn't see this function because this is an external function. So if you instead put it public, you see the error disappears because now this contract can call, of course, this function, which is changing the visibility, right? So this is another way we could do basically the same thing we were doing previously, right? So we get this user and we check the user address. If the user address is the 0 address, it means it wasn't initialized, like that user basically does not exist. So we can proceed. Otherwise, we return an error. And this is like two ways that we have to return errors, okay? So doing require or doing like if-else statements with the revert keyword. So this we say revert, we have a sort of typed error with some parameters in it. This instead is just a string, an error string, okay? Okay, so as I was saying, here external always. Here you can put public, internal, view, whatever. Okay, but this function needs to be actually implemented inside the smart contract. Otherwise, it just won't work. Okay, so this is basically, let's say, how you use like one way of using interfaces. But there are two other ways to use interface. So the first thing is basically, let's say, okay, so let's say that I don't really want to do this. Okay, let's say that I already created my smart contract, and let's say that I already even deployed it. Okay, so we need to put, since I'm not inheriting this interface anymore, I need to redeclare my struct here and my events. So let's say that I already created this smart contract and I already deployed it, and it's not upgradable, right? So it's kind of too late for me to say like, ah, no, I wanted to. It was maybe nicer with an interface or stuff like that, because actually. It's not mandatory to have the interface. Okay, you can just write it like this, and it works, and it's fine. And you have the ABI. You can interact with it, and everything is okay. But actually, you already deployed your contract, so on. So you're like, okay, but I want other contracts, okay, or other people to know exactly like this, what is the skeleton of my smart contract. So I want to have an interface so I can just show to people like, hey, this is what my contract is doing. It has those functions, so I can pass you this interface. And you can say like, okay, I know that the contract that Dan wrote has those two functions, and I want to add another contract of mine that maybe interacts with those functions. So let's say that you have maybe we create a contract, let's say my class, I don't know, my class, or let's say redeem price. That's all. So what will this one do? This contract, let me just copy like this. Okay. So redeem price. Okay. So let's say that we want to send some vet to whoever participated because we called it first smart contract, but if you look at the interface and everything, right, it seems like I have a user, I can add users. So I want specific users, like only users that were registered in this smart contract by someone else, maybe even, to be able to claim something. Okay. So let's say that we want a function claim, which is public. Yes. And what this is doing, we need to check. Let's remove this. So we want to check if the user was added to first smart contract, right? So if the user is present in there and it was added, then we say like we return, we just send that, okay, something like that, send that to the user. So right now it's like, okay, but how can I check this? How can I interact with this smart contract? Okay, so first of all, you have your interface, so you know that the first smart contract that contract is implementing all the above. So what you can do, you can select, okay, I will import this interface, so like this. So right now it's basically like I have like this sort of ABI, right? Because if I click here, I can access those methods, or at least I know that it's possible to, like, this smart contract or the contract that actually implemented this interface can access those methods. And what I need right now is what? I need the address of that contract, right? So let's let's store in the storage first our contract. So we say I first smart contract, private first smart contract, something like this. Okay. So what this means, it means that I have a variable which is first smart contract. Okay. That the type of this variable is the interface. Okay. So it knows, since the type is an interface, basically Solidity knows that this is a smart contract. It's not just a normal variable. It's actually a smart contract. And it's a smart contract that has the following functions. Okay. So now we have our variable to say, like, okay, this is for our contract, and we need an address, right? Because, like, hey, where do I point, right? So we have our constructor. Good. So we have our constructor, and we say, like, okay, I pass an argument to this constructor, which is the smart contract. Let's put address like this to make it a bit more clear. Okay, that we put the address. And then what we want to do, we want to store it, right? We want to store it here and say, like, okay, this is our smart contract. But before storing it, we are passing the address, right? So we cannot do like this. If we will do like this, like we did in for the owner, it's actually, you see that Solidity is saying, like, no, this is wrong. Why? Because this is type address and this is type interface of a contract. So it's not working, right? So we need to basically parse it. Okay. So how do? We say, like, hey, this address is of type first smart contract. We do it like this. So by this, we are parsing it and we are saying, like, okay, this is, we are saving it, actually, like, we are pointing to a contract, right? And everything's okay. And right now, what we have, we in here, in our function claim, we get, I don't know, like, address claimer, who is the claimer, is the message sender, right? So it's the one that is actually calling this function. But if you want to make it available for anyone to claim for whatever user, we could even put here, pass it as an argument, right? So claim something like this. So we don't need this, but let's say it's only the message sender. So we have our claimer. What else? We have, and now we want to check, right? Like, check if the user was added in our first contract. So what we do, we take our variable, our contract here, which is first smart contract, and we can, you see, I click a dot and I can already access all the methods. Okay. So, and by the way, sorry, just like this, like suggestions that you see is actually a package, an extension. So if you just search here for Solidity, yeah, you can find Solidity, you install it, and you will have the same. Okay, so as I was saying, I just put dot and I say get user, get claimer. Okay, so what we can do now, so we can say, like, okay, address claimer from contract is some random stuff I'm writing uh, from contract. Okay, but actually it's not an address. Yeah, so this is the error, right? Because we know, apart from the grammatical error, we know that this function is actually returning a user, so a struct like this, right? So we actually need to declare it differently. So we need to say, like, we need to access this interface and we need to access the user. So we say, like, this claimer from contract is of type user from this interface. And now why it is complaining? Because I need to specify like, hey, you're declaring these variables. Should I store it in the storage? Okay, should I store it in memory or call data? Memory and call data are basically the same thing. So as I said in the previous lesson, storage you could think about it like saving in the hard disk, right? So computer goes off, the file is still there, the information is still there. Memory like RAM. So once you enter this function, you store it, you exit this function, delete. Okay. So here, for example, we don't need to store it for long term. It's just a thing we will need inside this function. So we say like, okay, memory. Okay, so now we have our claimer from contract, we have our the message sender, the claimer, and what we want to do, we want to check like, okay, or even require, let's do if claimer from contract. Okay, so if this one here, if the user address of this one is different from the claimer. Okay, so if this address here, which is the person calling the contract, is actually different from, well, we could say like this and it would work, but I think the best way where is like ChatGPT suggesting here, which is like saying like zero address, right? Because it's basically the same thing. Because if this, sorry, if it's equals. So because if this is equals to a zero address, it means that he didn't found any user, right? We could even add another function here, like does user exist or stuff like that. So we don't need to do this check every time, but we already did it like this. So let's move on. So we say like, hey, if the user does not exist, then revert it. And we say user not found. Okay. Otherwise, continue. So to continue, what we do, we say like transfer. So it should be like this dot transfer claimer. No, I think it's just transfer. Let me check. Kind of don't remember, but that doesn't matter. So we basically, yeah. So we just add whatever logic we need here, okay? But in here, what we wanted to show is like how we interacted with another contract, right? So and why the interface is actually needed, okay? Because you need it for other contracts to interact with your contract. And actually, like this interface, it doesn't need to be written by the same person that wrote the smart contract. So maybe I wrote this smart contract and I deployed it, but then the other person that wants to create this redeem price smart contract says like, hey, I need to interact with that one. I don't find any interface, but I have the code because maybe the code is public. So yeah, I will just create a file. I will call it interface for smart contract, and I will use it inside here. Right? I could even call it differently. I could even call this one I class students, whatever, right? I call it like this. It doesn't matter. Copy paste, and it's the same thing, right? Because what actually matters are the functionalities inside here. And try to think about this like one of the most major use cases for interfaces is like for creating also standards. So if you think about blockchain and you think about tokens, like we have ERC20 token, ERC721 tokens, like the NFTs, right? So all of those, what are they? They are just some smart contracts. Sorry, they are just some interfaces. So you are basically saying, oh, okay, like let's all agree on some standards. So let's all agree that if we want to have a token on the blockchain, that token must have a function called transfer. That token must have a function called the balance of, right? That contract must have those 3 or 4. Actually, we can take a look at the interface. So let's look at the interface. Okay, so you see here, like we are saying, like, okay, we need the events called transfer and all this stuff, but then we need a function to actually transfer the tokens. Okay, and this function needs to have an address to which is the recipient and the value, the amount, a balance of, and so on. Okay, so you define this this interface, and now this is good. Why? Because all the wallets, they know, they say like, hey, we support ERC20 tokens. Okay. And when they say that, what they actually mean, they support all the contracts that has this interface, that has those functions. Because basically they just assume, they don't know what is your actual code of your smart contract of your specific token, because Better, for example, has a different implementation from both token. Okay, but both of them, they inherit the ERC20 interface. So we know that for sure both of those tokens have a transfer function, allowance, approve, and so transfer from. So the wallet can just be agnostic of how each token implemented the Solidity code, and just saying like, hey, I will work only with ERC20 tokens. So everything that has the following functions for me is accepted. So I can just build a button that says transfer where I call this function here, and I don't know exactly on what contract address I will call it, but I know that I will call it on a ERC20 token, right? So yeah, so right now you have an interface and everyone is aligned. They know that if you want to build your own token and you want it to be compatible with exchanges, with wallets, marketplaces, and decentralized exchanges and so on, okay, I need to implement the following functions. Okay, maybe you don't even inherit this interface this way, but you know that you need to implement the following functions. Otherwise, you will have problems. You will have integration problems, right? Because you created something only specific to you. Okay, so those are the interfaces, but what else? Let's say that in here I want to actually reward the user instead of with the bet, which is actually like, let me check. I have like blank right now. So Solidity transfer Ethereum. Okay, so uh, what's this? Recipient send. Okay, so we need an address. So for example, here, this is our claimer. So we say claimer send 1 Ether. Does it work? Yes, it works. But it says it gives an error. Why? Because this is a simple address, okay? But in order to be able to receive payments, you need to parse it. Okay, the same that we did here. You need to parse it to say like this is a payable address. Okay, payable address. It means that it's an address that can actually receive money. Okay. Okay. So it says transfer. Okay. I was remembering this transfer. Okay. So like this, we are sending 1 Ether. Of course, this we need to check, for example, like if this contract even has enough money. So we will need to do something like uh, this this balance. Yeah, I don't remember now. But let's say we need to also like check if contract has enough balance before doing it. Otherwise, other otherwise revert. Let's see if ChatGPT. Yes. Okay. Thank you, ChatGPT. So we say like, okay, this address. So this is another like way of accessing your own contract. Okay. So you're saying like an address of what? This is how you parse variables, right? We saw it here, we see it here, we see it here. Okay. So we say like, give me the address of this contract and check the balance. Okay. Because it's also like, well, if you say message, you can get data, sender, value, and so on. In this way, you can get the balance. And you say like, okay, does this contract even hold enough money to send, right? And then you send. But let's say that instead of sending Ethereum, we want to send one of our ERC20 tokens that we created, right? So in that case, it will be very similar to how we did it here, okay? So first of all, we need to import the interface that we were seeing before. So let me just copy. Let me see if I can just maybe copy this file. Yeah, I can just copy this. We go here and we say ir20.sol, okay, and we paste it. Okay, so we have our interface and we say we take it from here. Okay, and we say like, oh, I have 20, which is private, which is not the bad token, but the reward token, right? So we have our token. Here we need to specify the address because otherwise we don't know where to point. So we do it. We say the reward token is an ERC20 token that it lives at this address, right? So in here, we do basically the same. So instead of sending that, we send a token and we say reward token. Okay. We know that in here, like if I press dot, I see all the available methods from the interface, right? So we say transfer to who? To the claimer, okay? And we don't need to put variable or that kind of stuff. So we say to claimer and not one Ethereum, but yeah, the amount of tokens, right? So actually, this is not wrong because this is just the unit of measure, right? So I was showing you in the previous lesson way to that Ethereum, like it's actually like a unit of measure. So if I write here one, just one like this, what it means, it's one way. So by default, Solidity it's thinking like in way, right? So if I write one, I will actually send this amount of my token, a very low amount of my token, right? So if I want to send, like, and here it's Ether, but it's just the unity of measure, right? And because every token, both Ethereum and a token is like 10 elevated at the 18. Like this is the amount of zeros that you have, right? You can maybe change this, of course, when you create your token, but by default, it thinks of way in that unit of measure. So if I want to send, for example, exactly one unit of my tokens, I can put like this, or I can say one ether. Okay, it's the same. So I will send basically one token to whoever claims this. And of course, this require also change, right? Because what we need to do, we need to call the reward token and we need to say like, hey, and it was once an address. So does my contract have have more than one Ethereum, like one unit of tokens of this reward token? Okay, because if otherwise not enough balance, if instead it has enough, then proceed and send this token to the claimant. Okay, so what we saw here are implementation of the interface, what it is and how you can use it, and some of its rules, right? Yeah, I actually I had to run more. I thought I would have more time. So let's go. We already touched a bit about the inheritance, right? Because in here, the first time we implemented inside it, the first smart contract. So is I class students, and we need to remove this. Need to import this. Okay, so this we are basically inheriting this contract, which in this specific case is an interface, right? And by the way, you can inherit many interfaces. So, for example, if you have if you want this contract as well to, let's say, be an ERC20 token, you could say that it's both an ERC20 token. So this first smart contract now needs to implement both the functions inside class students and also inside ERC20 token. Okay, in fact, it's red and it says like, hey, should put as abstract because I need to implement all those functions, right? But I can do it, right? I can do, and this will basically become now both an ERC20 token with some custom code that you can add users or whatever. Its contracts are kind of liquid. Okay, so this is already like you're inheriting something, right? But let's go a bit deeper. So I was saying before, for example, that if I don't add this function here, it will complain, right? It will complain. Well, first of all, here, of course, because users user address, okay. It's complaining because I didn't implement that function. So let's say I put abstract in here. Okay. So what I can do right now, and it compiles, as I say. So if I say yarn compile, it should compile correctly. But if I do yarn deploy, let's do solo. My okay. What? Okay. Okay, we have our solo. I just started the solo Tor node on my local. And if I try to actually deploy this, yeah, you see? So you're trying to create a contract factory from this one here, but this is abstract and you cannot deploy something abstract that did not implemented everything, right? So what you can do, for example, there are a lot of cases where you actually want it to be that way, okay? There are a lot of cases where you are saying like, hey, I want to to create a contract that I then publish publicly, like on GitHub, open source, where I implement a lot of logics, okay? But I leave some functions to the developer, the final developer, let's say, to implement them. For example, it could be like the name, right? Or something like that. So you're actually basically building everything, but you're saying like, this is an abstract contract, so just inherit this one, declare the missing functions, and go with it. Okay, and it happens actually a lot of times. But so in our case, what we could do, completed contract, we could do like this. Dot solve. We let me just copy this one. We put like this contract completed contract. Okay, and we say like this contract is first smart contract. Okay. Okay, so now what this means, so this is not an interface anymore. So what this means is that the moment that we will compile this code, basically the output will be one big single contract. Okay, so all the functions that we see in here, you just imagine that all this code is basically right now inside here. This is what this inheritance means, right? It will put basically all the code is inside here and is accessible. It can be accessed by completed contract. Okay, so we put it there, but we still miss, since like even if first smart contract is inheriting the interface of class students, and here we are just inheriting a first smart contract, we don't see any interface. It doesn't mean that we are basically inheriting this one, which is inheriting this one, right? So we still need to comply with all the logics, because as I said, imagine that when you actually compile the contract, it's just one single big file, okay? One single big contract altogether. So we need to specify something here. So what was the missing function? I don't remember. I think it was get user. Get user. So I say function get user, which is public, which returns a user. And by doing this, you see, I can even access this one here, this mapping here, even if it's another contract. So now, one thing, if I put here, so when we declare variables, you see I can say private here, and mappings as well, I can put here private, okay? If I put private, it means that this variable is accessible only by this contract. So in here, you see, it's red, because since I'm inheriting from here, I cannot access that one. It's still like only accessible from this first smart contract, right? So if I put it instead internal, then I'm able to access that storage. If I put it public, it's by default public. So if I don't put anything by default, it's public. Okay, so I created this, I can compile. I can compile and everything works, right? So I have my contract. So when I will deploy, I actually now, it's like in my deploy scripts, I don't need to get the first smart contract. I actually need to get the completed contract. Okay, why? Because this is actually like the entry point, right? This is the main entry point, and from here you can go deeper and deeper and deeper and deeper, right, until you reach the end. So I need to take this completed contract into like from here, and then I say like, okay, let me also change it. Completed contract, deploy. Here we have a constructor, okay, nothing, okay, so everything is okay. Yeah, so basically, if I do like this, and I say deploy solo, it will deploy it. Okay, so now one thing. So what can happen though, let's say that this first smart contract actually already implemented everything. So let's say that instead, because in this particular example, or actually let me think, let's say that I have another contract, which is second plus students, something like this. Okay, and this contract is actually very similar to this one. Like it still uses this interface. Doesn't have any owner. Okay, and but already has this function here. Sorry, my bad. A second. So, okay, it's abstract, but we have this function here. We don't have the user, so we will need to do the same. So let's do like this. Okay. So what this one here actually implemented is only the get user. Okay. And it's saying like, hey, I don't care. This may be something easier to follow as an example, but you implement just one function. So in here, in our completed contract, for some reason, we actually want to take all of them. Like we want to inherit also that one, okay, second class students. Okay, and now we have a problem, right? Because what we have here, we declare this get function. Why? Because we were missing it in here. It was missing, right? But then we inherited this other contract as well that already has this function. So it is saying like, hey, like what like you're doing, like you have two different function with the same name, blah blah. So there is we need to specify what we are doing here, we need to specify that we are overriding, okay? Why? Because it's already declared in here. So, or I completely remove this, and if I remove it, it will work, okay? Why? It will work because here we are missing that function, here that function is implemented, but the main entry point is completed contract. So from this point of view here, like everything is fine, right? I have all the functions, everything is fine. But uh, let's say that I actually want to, as I said, and I use this term override, which means that I don't want to use this thing here because maybe in here we have some, there are some checks and maybe something else. I don't know, there is some logic, something that I don't like, I don't want to use it, right? So I would like to override the function. So you can do it by specifying like override. Okay. You can specify like, hey, I want to override all the functions with this get user, this signature, right? And use this one instead. So of course here, Solidity is complaining because it says like, hey, you need to specify what contracts you are overriding because you have this get user function, which is specified both in the interface and also in the second class student smart contract. So I opened here and I say like, hey, I just want to actually override both of them. Right? So you put like this. And I need, of course, to import it in order to be able to use it. Okay. But there is something, I'm not sure, Solidity seems to not catch it, but this is actually wrong. So let's see if it compiles first. Yes, okay. So why it is wrong? Because first of all, actually it fails because I have like this mapping with the same names, right? It's kind of wrong. So let's put 2 here, whatever. Okay, so I'm trying to override, but it says, but in order to be able to override a function, actually you need to specify it at the origin, okay? So when I declare this get user function in second class students, there is another keyword, a new one this time, which is virtual. So you can put this virtual keyword, which means that all other contracts that inherits this one can override this function, okay? Can override it, so they can change basically the whatever the execution of the code inside it. So in here, for example, since you see, I shouldn't see any error. Yes, everything works fine. So I'm saying like, hey, go and look into those two files. Okay, inside those two files, you will find a function with the same signature. And when I'm saying with the same signature, I'm saying that its function get user with the same parameters and with the same return times. That's a signature. Okay, so I'm saying like go and look into those two files. Okay, and what I'm doing here, I'm actually overriding. So when you will compile all this code and so on, and someone will call get user, don't go to those two functions, go here. Okay, come to this function here. So in this function, maybe we just return, for some reason we say revert function, functionality not implemented yet, and it's actually like parentheses. Okay, we do something like this, right? So so right now we compile the AB. So let me compile and let me look at the artifacts in here. Let's take a look. This is the completed contract like this. Let me search for get user. Okay, so I have the signature of it. I have get user, all the outputs, components, blah blah blah, stuff like that. So I can call this function. It's possible to call it, but when I call it, it won't go here. It won't go neither here, interface, whatever, but it will go inside here. Okay. And now we have a few possibilities. Okay. The first possibility is to put our own code in here. Okay. So we say, do this or do the other. We just write some Solidity code and that this one will be executed. But another option that we have is to say like, hey, what I want you to do, I want you to actually call the other functions. Okay, I want you to call the second class students function or the first class contract function. And to do that, what we use is there is this other keyword, which is super. Okay, so I say super get user. Okay, so super get user, what it does, it will go and it will look in those two contracts and it will search for get user function, and based on the order that you inherited that those contracts, you will run those. Okay, so the order when you inherit is from right to left. Okay, so this one has the priority over this one. So Solidity will first go and look into second class students, and it will go here and you will say like, oh, is there any get user function? Yes, there is this one. It will execute this function. Okay, then it will go inside here. It will search, is there any get user function? No. Okay, then that's enough. Okay. Usually you don't have many contracts in the override here. Usually it's just one contract. And so let's remove this from the equation, this second class. Oops. Let's remove the second class students from the equation. We do like this. And let's say second class students, let's say that inside here, we already defined our function, right? So as it was originally. So we already had this one. And so, sorry, let me go here. So here, we don't actually need to specify anything, okay? Why? Because it already knows that there is only one function with get user that it's in here, okay? Previously, I was putting in the parentheses because I had two different contracts, each with this function signature. So I had to specify what I'm overriding, okay? Here, Solidity just knows that I'm overriding another function with this name. But I can override it because it's virtual. So this is important. You can override only virtual functions, okay? And also, when I override it, I can put also here virtual as well. I can say virtual, okay? So I'm saying like, hey, I'm overriding that get user function in the second contract, but if some other contract wants to inherit me, you can override me as well, okay? So you can go multiple levels. So you can say super get user, and it will go directly there. What you can say, you can even say like add some logic here. So do some checks, whatever, okay? You put your Solidity logic in here, and then only at the end you call the original function. Okay. What you can do, you can also do this. let's say that in here we were using get user as before, right? We were calling get user with the user address. But for some reason, we don't have the capacity, or we don't have for some reason, we don't want to implement this here, like the logic here, right? What we can do, we can just declare it, okay? We declare it, we say like this, get user must return, actually returns, it's a view function that returns user. Like this. So if you put it like this, what it means that this is accessible, but the contract knows that, hey, you just declared it. You put it virtual. You didn't add it all the logic, right? So, and like when you will actually override it here, and here also it's actually not, you don't, you cannot call super because there isn't anything to call here, right? So you just add some logic in here. You do like this. And as I said, at the end, the contracts are compiled together. So it knows that this function, it will call it here. Okay. So overridings, you can do some tricks here and there, but they are also powerful. So for example, let me first think if something else to add. Yeah, super override. You can override many. Yeah, the virtual. Okay. So one important, because like you could use, and I wanted to talk about it today, but yeah, I'm not doing it in time. So Piero will touch it in the next lesson. So you have actually big public libraries, okay, with full contracts. And OpenZeppelin is one of those. Okay. So if you search OpenZeppelin on Google, you will find this one. So in here, you're basically having a lot of smart contracts already written for you. Okay, you even have this here, wizard OpenZeppelin, where if you go here, you can create things, right? Like for example, ERC20 token. You say like I want to print this amount. This is the name of my token. This is the symbol, and I want it to be mintable, whatever, and access control ownable and stuff like that. So basically, you have here, like this is your final contract, but why it's so small? Because you are inheriting other contracts. Okay. So for example, yeah, so I was doing the example of ERC20 tokens because by this, oops, sorry, by doing this, by overriding functions, you could, for example, override the transfer function. So you could say like every time a transfer occurs, let's burn 1% of the supply, right? Which a lot of meme coins did. So you just, to create your token, you just do like this, basically. You just say like, hey, I'm taking all the Solidity code that people already wrote, and it was audited, everyone is using, so I'm not risking to do any damage. This one, of course, it's inheriting the interface on ERC20, but I want to add, change it a bit, right? So you take, and if I open this is the contract, you will see that there is a transfer function, okay? And you see it's virtual. So it means like, hey, I implemented this. What it does is doing this, it's transferring the tokens this way. But if you want, you can override it, right? So maybe in my code here, I cannot write it here, but I can just say function, function transfer, blah, 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 all of this, override. And I can say like, okay, before I can say like burn 1% of the supply, and then super.transfer. Super.transfer will then call this one here and will proceed as usual, right? But before actually proceeding as usual and doing the transfer, you're burning 1% of the supply. Okay. So this is one way. Um, like yeah, like one important thing about like virtual and overriding and this stuff, like, so if anytime you're looking for implementing some other external contract that was written by OpenZeppelin or by someone else, just check like, okay, can I override something? Like what like how many constraints do I have? Because for example, if you couldn't override it, then it wouldn't like, yes, it will be easy to implement, but then the trade-off will be very big because like you don't have any power on your token that you created, right? You cannot change basically anything of it, right? But instead, it's everything is virtual, stuff like that, so you can override. Uh, Another thing, yeah, I was forgetting this. So let's get a bit back to our first smart contract, and this is the last thing. So we talked about OpenZeppelin, and to use those contracts, you see this repository here, they are already actually inside this template, but you need to install basically a package, right? So it's this one here. You install OpenZeppelin contracts, okay, and you can access those contracts from inside basically your own contract. So here, for example, we were having this ownable, right? So we were using this, we created our own contract owner variable, we created our own only owner modifier, and our own get owner and stuff like this. But OpenZeppelin, actually, they have already, they create a contract for access control and stuff like that, which is ownable. So ownable from here, from OpenZeppelin contracts access control. Import. Okay, so if I open it, here it is. So what we have here, we have a variable owner, right? We have a modifier, only owner. We have a function to get the owner. We have another function to check the owner. We have a function to transfer the ownership, right? Because since we are to know if you are a owner or not, we are just saving an address in a variable, right? We can change the ownership by updating the value in that variable, right? So this contract comes with everything about this, right? So you can even renounce ownership, right? So I'm like, okay, why do I need to write my own code for this particular thing and maybe risking even to do some mistake? So yeah, let me just make it ownable. So I come here and I say, my contract is ownable. So it means that I have all of this. And in fact, you already see that the modifier is already specified in the OpenZeppelin contract. So I must remove this. I must remove this as well, and I don't need the get owner anymore. But there is one thing. I cannot do this, right? I need to initialize that value. So if we go to ownable, we will see that it also has a constructor. So you can have, and you also see it's abstract. But basically, you can have multiple smart contracts, each with their own constructor, and you can inherit them in your own contract, right? In a single contract, a single entry point contract. So since this one has a constructor as well, we actually need to specify it here. Okay, so we need to specify because instead of doing this, we don't need it anymore. But what we need to do, we need to call the ownable. We do it like this, ownable, and we pass message.sender. Okay, so you see ownable, name of the contract, the constructor accepts an address, the initial owner, so we just put it here. So our own constructor does nothing, but we are also concatenating the other constructors of the other smart contracts, right? So we do it, we compile, it works, we can I don't know, we can deploy and do everything. So now it's a lot better, let's say, because I don't have to worry about all this access control, let's say. And just to look a bit deeper, like here, for example, we have ERC20 and ownable, right? So we have what we have here. We have ownable, initial owner, right? We have our ERC20 smart contract also wants two information. So if you go inside here, we will see that there is a constructor. which is name and symbol. So we are passing the name and the symbol, right? And put it in the same line with the constructor. So yeah, so I think I can actually end it here. I wanted to do too many things, but it's still okay because this inheritance and inheritance in particular, but also the interfaces are used a lot, right? Every time you need to interact with other contracts, you use interfaces. And every time in the day-to-day coding of Solidity smart contracts, you will always use inheritance. Like that's the basic because 99% of the cases you will use something from OpenZeppelin smart contracts. And to use those, you need to inherit them, right? So understanding that how to initialize the constructors, how to basically override functions in there, it's important. Let me see if here there is something that I can override. Yeah, basically, I think a lot of things. So renounce ownership, maybe I can override this function here and I can say like function renounce ownership and this is public, only owner can call, I'm overriding it. Can be restricted to view, yeah, view. But let's say that I actually want to call public. Yeah, sorry. Okay, I actually want to call this function here, so it does whatever it is doing here. You see, like address, old owner, new owner, and this is transfer. Sorry, yeah, transfer, but it's transferring to address 0, right? So no one will be able to be that owner. But let's say that before doing that, I could say like, hey, I want to allow the renounce of the ownership only after a specific block. Okay, so maybe during the deployment, I say like this contract can be renounced from block 2 million, which is maybe from 1 year from now. So in here, I maybe just add a check. So I say like require that the block number, the current block number is higher or equal to the specified block number at the moment, something like that. So yeah, that's basically it about inheritance, about interfaces. Thank you, everyone. See ya.